This is Dr. D. Govardhan, Professor and Head, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, we are discussing the second unit, friction. Okay, the topic is Introduction to Friction, Limiting Friction, Laws of Friction, Important Terms used in friction, and types of frictions. So, what is the meaning of here friction now? Because if you observe the surfaces by touching with the hand, it will create just you can experience some roughness. That is, every surface is having some roughness. Even though the mirror is there, when we are touching, it is observed as smooth. But when it is viewed under microscopes, some irregularities also we can see on it. So when one object is kept over the another object, this irregularities, it is in the form of conical shape. Like that means in the form of like this. Here, one object, when it is placed over the another object, this interlocking, this irregularities, when it is matched with each other, that interlocking is taking place. As long as the work is stationary, the effect of interlocking is zero. But when the body tends to move over the another object in any directions, the interlocking is always oppose the movement of the body. This opposing force, which acts in opposite direction of the movement of the block, is called force of friction. Simply, it is called friction. Here, the friction force, when the object is at stationary, the friction force is treated as zero. When the force is applied over the object, which is shown in here figure P, pushing force, the body tends to move in the direction of applied force. It may be the applied force, it may be the less force. On increasing the force gradually, the friction force is also proportional to the applied force up to certain limit. After that, it tends to move in the direction of applied force. The maximum friction force that is experienced between the contact forces, when it tends to move in the direction of applied force, that frictional force is called limiting friction. That is, the limiting friction is the maximum frictional force that can be developed at the contact surfaces when the body just on the point of moving is called limiting friction. The friction exists between the two bodies when they tends to move related to one another. Different types of frictional forces that exist depending upon the type of motion that is taking place between the two bodies. They are classified as first static friction and dynamic friction. The static friction is the friction that is experienced by a body when it is at rest is called static friction. Here in the figure number 1, this I am showing, the force is applied on a body, stationary body. The frictional force is also increases. It depends upon the magnitude of the applied force up to certain limit. After that, the body tends to move in the direction of applied force. At that moment, the frictional force which exists between the two contact surfaces is treated as the maximum frictional force. It is also called limiting friction. So the frictional force which exists when the body is at rest, that is about to start, it is called static friction. Dynamic friction. The friction experienced by body when it is a motion, it is called dynamic friction. The dynamic friction is always smaller than the limiting friction. This dynamic friction further classified into sliding friction, rolling friction, depending on type of relative motion taking place between the contact surfaces. The sliding friction is the frictional force experienced by body when it slides over the another body. It is called sliding friction. Here example, the body is there. Now it tends to move toward the right side. Here this is the surface of the body. That it is moving in the direction because of application of the force P as shown in figure now. It is called motion now. The friction force exists between these two contact surfaces because of sliding is taking place. Hence, this frictional force is called sliding friction. In second case, the roller is rolling over the surfaces. The frictional force which exists in between the object which is rolling and the body on which it is rotating is called rolling friction. Here I am taking here the object is there. It is now rolling over the table now. The friction force which exists in between the rolling body and the surface of the table is called rolling friction. Coefficient of friction. Here I am taking just first figure now. The body is resting on a horizontal plane. A force P is applied on it to change its state of rest. So, initially, when the applied force is lower, the body it will not move in the direction of applied force. As the P force increases, at a certain stage, it tends to slide in the direction of applied force. At that instant, the frictional force which exists in between the body and the contact surface is called limiting friction. That is the maximum frictional force that exists. At this position, we are drawing free body diagrams. The free body diagram representing what are the action force as well as the reaction forces which are acting on a body. Here, the free body diagram is representing the weight of the object, that is W, vertically downward directions. Since the table is keeping the body in equilibrium positions, hence equal to W, that is weight of the body, in the opposite directions, normal force that is existing on a body to keep it in equilibrium positions or to balance the vertical forces which are acting on it. When the body tends to move, that means the applied force P is acting toward the right side of the object, and the frictional force is always existing in opposite direction of the body tends to move, that is toward the left side. That P as well as the F both are equal in magnitude and acting in opposite directions when the body tends to move only. These forces are again represented in figure number 2. The frictional force as well as the normal reactions both are acting. These two forces can be represented as two adjacent sides of a parallelogram. Then the diagonal which is passing through the point of intersection is representing, it is the resultant of the two forces. Or by using law of triangle, If the two forces are represented as the sides of a triangle taken in order, the closing side is representing the resultant of these two forces both in magnitude and direction but in opposite order. Hence, here frictional force is F is represented here now. It is representing both in magnitude and directions, and any the normal reactions that is acting. The resultant of these two forces is represented by here R according to the law of triangle. Now, at this stage, the ratio of the limiting friction to the normal reactions is always be as a constant. This constant is called coefficient of friction. Here, according to the problems, F is the representing frictional force, N is representing normal reactions. The ratio of F to N is called coefficient of friction. It is always represented here mu naught. Angle of friction. Here in figure number 2, here R is representing resultant of friction force and normal reactions when the body tends to slides over the surfaces due to the application of the force P having its weight W. The inclination between the resultant of frictional force and normal reactions with the normal reactions, here it is represented by pi. This is called angle of friction. That is, the angle of friction is the angle made by the resultant of frictional force and normal reactions with the normal reactions, and it is also called limiting angle of friction. Angle of repose. Here I am taking just one horizontal surfaces, assume. The body is kept over it now in static conditions, that is at rest. The weight is acting vertically downward directions, and the reactions offered by the surfaces on the body is called normal reactions. Since there is no force acting on it, hence it will not slide over it. But holding the figure just here, the surface is at point now, and applied the force at other end, such that the surface makes inclinations like this. That is gradually tilting the plane. But at some instant, the body tends to slide downward directions without applying any external forces on it. The angle at which the body tends to slide downward directions is called angle of repose. The reason here now, the weight is there, it is always vertically downward directions. The normal reaction is always perpendicular to the surface, it is representing. These forces are there now, that weight is resolved into two components. One is acting in downward directions, one is perpendicular to it now. This perpendicular component is balanced with the normal reactions, and this horizontal component of weight W cos theta tends to slide the body in downward directions. So when it tends to slide means the inclination of the plane with the horizontal at which the body tends to slide in downward directions is called angle of repose. At this moment, the coefficient, the frictional force F is now becomes F is equal to W sin theta values, where theta is representing the inclination of the plane at which the body tends to slide downward directions. This inclination of the plane is called angle of repose. Now I am taking the equations now. At these conditions, when the body tends to slides in downward directions, the vertical components are, one is normal reactions and another one is here W cos theta, both are equal, hence N is equal to W cos pi, which is represented here now, equation number 1 now, cos theta now. The second one is when the forces are resolved parallel to the plane, that is the frictional force is always balanced with the sliding force, F W sin theta. The dividing this F by N is equal to, we got to tan theta. It is also equal to coefficient of friction, which is represented tan pi now. Or in other words, tan theta is equal to tan pi, or theta is equal to pi, or in another meaning, the angle of repose is always equal to the angle of limiting angle of friction. Cone friction. In the figure, here W is the weight of the body that is resting over the horizontal plane. A force P is applied on it, which is in horizontal. Assume at this stage, the body tends to slides in the direction of applied force. So, on resolving the forces, W is acting downward direction. The friction force is always acts in opposite directions in which the body tends to move. N is the normal reactions. Hence, P is always equal to now F and N is always equal to W now, where F is called limiting force of friction. That means at which the body tends to slide in the direction of applied forces. So, according to the law of triangular forces, the F friction force and the normal reaction both are represented as sides of a triangle. The closing side is here it is representing the resultant of these two forces. Here it is represented by R now. But according to the angle of friction, the angle made by the resultant force with the normal reactions, here this is called angle of friction. Here when the body tends to move toward the right side, this figure is applicable now. But if the body tends to move assume toward the north side, that is the other direction now, like this, again the friction forces act in opposite direction of movement and normal reactions also exist in such a way that it is again in the direction of like this, but it is constant with the 90 degrees now. Or if you take that the cone, if it is there, the first one is representing when the body tends to move toward the right side. This is again representing, this dendrite is representing the resultant of friction force and normal reactions when the body tends to move is in the direction of previous, in the direction 90 degrees to the x direction. That is when we are moving from 0 to 90 degrees, the resultant forces also tends to move from initial positions y it is there, that is 90 degrees somewhere here, assume R1 position. Similarly, when applied forces is applied at an angle of 180 degrees to the initial position, that is towards this direction now, the resultant force now becomes this direction now. That means when the force applied is rotated from 0 to 360 degrees, the resultant of frictional force and normal reactions will always follow the locus of right circular cone or in the form of right circular cone. In right circular cone means the axis is always perpendicular to the base of the cone now. That means here this is called axis now, here O, and this is called the generators. These generators are infinity are there now, and it is always the resultant of normal reaction frictional force. When the applied forces are changing from 0 to 360 degrees, the resultant force is also changing in such a way that it will also rotate 360 degrees in such a way that it is in the form of cone, and its diameter is equal to twice of the frictional force, and axis length is equal to normal reactions. The generator length is treated as the resultant of frictional force and normal reactions, and this phenomenon here called cone friction. That means when a body is having impending motion in the direction of P, the frictional force will be limiting friction, and the resultant reaction N will make limiting friction angle with the normal reaction as shown in figure. Thus, if the direction of force P is gradually changed through 360 degrees from 0, the resultant R generate a right circular cone with a semi-central angle equal to alpha. If the resultant reaction lies on the surface of this inverted right circular cone, whose semi-central angle is limiting frictional angle alpha, the motion of the body is impending. This inverted cone with the semi-central angle equal to the limiting friction angle is called cone friction. Laws of frictions. According to our previous discussions, the frictional force is always acts in the direction opposite to that in which the body tends to move, and the frictional force varies from 0 to limiting friction. It depends upon the applied forces. Till the limiting value is reached, the magnitude of the frictional force is exactly equal to the tangential force which tends to body move. The magnitude of the limiting friction bears a constant ratio to the normal reactions between the two contact surfaces. This constant is called coefficient of friction. Generally, it depends upon the surface roughnesses of the contact surfaces. The force of friction depends upon the roughness as well as the smoothness of the surfaces. The force of friction is independent of the area of the contact between the two contact surfaces. After the body starts moving, the dynamic friction comes into play. The magnitude of which is less than the limiting friction, and it also bears a constant ratio to the normal force. This ratio is called coefficient of dynamic friction. Okay, it is now. Just now we covered what is the friction now, what is the limiting angle of friction, and what is the limiting force of friction, what is the angle of friction, what is the angle of repose, the relations between the angle of repose as well as the angle of limiting friction, and the loss of frictions. These are completed in this class. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.